Hi, and welcome back. We are doing array lists and collections today. I want to make sure I've got all this set up properly. Whoa, I'm like massive. I'm unnecessarily massive. Well, just put me off into the corner over there. Um, oh, and wait, I have one more thing I want to make sure I edit here. Optimize for video clip. Okay, getting better at this. Okay, so we're talking about array lists today. So we're finally going to be able to use array lists for those of you who know what they are. And for those of you who don't, your mind is about to be blown. So our learning goals are actually pretty small for the week. We're just going to spend a lot of time practicing and getting used to using them and some of the sort of pitfalls of array lists. So we're going to learn about creating instances of array lists, using the built-in Java data type, uh, and using different Java data types with ArrayList, as well as like user-defined data types with ArrayList, and comparing and contrasting ArrayLists and arrays, um, and sort of how they differ and how they're the same for this lecture. Cool. So a quick reminder on how we store information right now. Right now, we are constantly using partially filled arrays. So we pick an array that has some preset maximum size, like on the assignment, like assignment 1, we had a preset size of 100, and then we had another integer like a cur items or num trees or whatever, and that keeps track of the current number of elements that are currently being stored, as well as sort of the index that we need to store at. So it starts at 0, and then it goes 1, 2, 3, 4, etc., which is great and helpful, except that there are, of course, some cons to this besides it being kind of annoying. There are size limitations, right? We're constantly setting a preset size. So we have to either automatically know how much space we're going to need or use like sort of reserve way more space than we need, or possibly constantly reallocate space and copy stuff over and shifting things over, which is a lot of looping and iterations over our code. And we're constantly tracking multiple variables. We have to track our array. We have to make sure that we know the max size, which is, whatever the size of the array is. So I guess that's built into the array, but still. And we have to keep track of the current number of elements in the array. So there's a lot more pieces to keep track of when it comes to partially filled arrays, especially when we're about to learn a way easier way of doing this, which is array lists. So Java has a built-in dynamic array, and it's called an array list. And it works basically under the Java hood exactly like a partially filled array, but it is way easier for us to use. So at the top of our code, just like we did with scanner, just like we did with file IO stuff, we have to import the ArrayList package. So we have to have an import java.util.ArrayList up at the top of our code anytime we want to use the Java built-in ArrayList class. And then we can just define an array list. So here, for example, we have an array list, and then in those pointy brackets, string R list equals new array list, pointy brackets, string, and then round brackets. Now, those pointy weird brackets are called generics. We're not really going to cover everything that goes in there, but for our purposes right now, anything you put in those pointy brackets is going to be the type of data that you can store in your array list. All right, if we define an array list, like as shown here, array list, like right here, array list, R list equals new array list without those pointy brackets, you can basically store any data type in it, pardon me, and then here is just showing how you could write it otherwise. So remember, we have that big object umbrella that all of our classes fall underneath, all of the user-defined classes, all the Java classes, everything is under the object umbrella. Well, writing it just like this without any of those pointy brackets is the same as writing it like this, saying you can store any kind of object in here. Now, there is a catch, which is that ArrayList can only hold objects. Now, it doesn't have to hold capital O object, it just can only hold things that are an object, like strings or person, but it can't hold int, it can't hold double, Boolean, char, float, anything with a lowercase letter, it cannot hold it. It can only hold things capital letter objects. Now, it's not actually a con. We can find a way around this. There are ways to hold integers, doubles, Booleans, etc. We'll talk about them in the next video. But we do have a way around using this, and in more recent versions of Java, they've made it really, really easy to use. So let's just go ahead and make some of these variables in some code so that we can just see what happens. I did switch my coloring scheme here to, hold on, I gotta move the meeting bar. Hide floating meeting controls, array list example. I did change my coloring scheme here to now be like, follow the color of my system settings so that when I was writing some code that I had to like port over into a PowerPoint, I wanted the syntax highlighting to stay, but it got weird when the background was black, so I had to make the background white. Whatever, doesn't matter. Anyway, here we are, ArrayList example.java. Where did I put that? I meant to put that on my desktop, but did I? Nope, I didn't. I didn't put that on my desktop because I'm a weirdo. Let's try that again. Let's try and save this again. ArrayList example, save it to my desktop. ArrayList example. Okay, sorry. Okay, so we have to have that import java.util.ArrayList up at the top. And then we can make our main. That seems very indented. And we can say ArrayList, whoops, string A1 is equal to a new ArrayList of type string, round brackets, semicolon. Perfect. We're just going to add our end of processing message here so that when I go to run my code, terminus, open default shell and panel, javax star.java. Oh, that doesn't spell Java. Oh, I didn't spell ArrayList right. Tricky. I'm like, what? I did import it. You got to import it spelling it properly. Now, when I go to actually run this, we'll see, okay, no errors, everything ran, it's totally cool with us. So that's great. Let's make another one here that will just hold objects. So we write it like this. And let's make one more that's going to hold ints, just to see how it's going to explode. Look at that. I've already got syntax highlighting on that's telling me that this is going to be a problem. So if you look at that, it's already highlighting in red. It's like, I don't know about this. Are you sure that that's what you want? If I try to compile that, what we're going to see is we will actually get a compile time error. Two errors. They're the exact same error because it's just on this one and on this one. But we have unexpected type, int. It requires a reference. It found an int. Reference meaning basically object, int meaning primitive. And then the same thing on the other side, it found an int, but it wanted a reference. So that's not going to work. We're going to figure out how to make that work in a little bit. But for now, we can see how to make array lists. Otherwise, we'll just work with one for right now. Okay. So whenever we think about objects, we really want to make sure that we're thinking about the acronym CRUD, which I know sounds silly, but it's actually quite helpful because things that we can do with objects are always CRUD. Create, read, update, and delete. Those are the things we should be able to do with any object. For example, let's think about arrays for a second. Pardon me. We can create a new array. We can read from an array. We can update values in an array. We can even delete elements from the array or delete the array as a whole, right? These are all things that we can do with an array object. And same thing with like a person object that we created in previous weeks. We can create a new person. We can read information from the person. We can update information from the person. And if we go ahead and we delete the person by just basically setting the variable to null or reusing the variable, the person becomes orphaned and garbage collection will come, clean up the person data, and it will be deleted. So even like individual objects, that's a thing that we can do. But let's look at it now with array lists. So this is massive. I'm not actually going to read all this because I know exactly what I wanted to do here, but we are going to make a class called my array list. And we are going to basically implement our own array lists. So if you want, you can pause the video here, read through all this psycho instructions, and make an attempt at making your own array list. I am going to not, and instead I'm going to do it differently. Now, we've done a person list before. When we first did objects, we made a person list. This won't be the first time that we'll have done something where we put an array inside some kind of object. So we're going to make a my ArrayList.java class, and we're going to have a private object array of items. We're going to have a private int cur items is equal to 0 to start. Well, I'll put it in the other thing. And we're also going to have a private int size. This should be final, I guess. Final int size increments. And it's going to be 10. And we'll see what that does in just a minute. Okay. So what we're going to do is we are going to make a constructor to make a new array list. Public my array list. And what will happen is this internal object is going to be set to a new object array of size increments. My current items is going to be equal to 0. And my, nope, that's it. Those are the only two things that I care about right now. Okay. So we're making basically an array of objects of size 10 underneath the array here. So if I go back to my main, which I definitely still have right here, and instead of calling ArrayList at string, I can even get rid of this. I'm not going to use ArrayLists in here for just a minute. Instead, I'm going to use my ArrayList. A1 equals new my array list. Make sure that works okay. Great. Okay, so now we're going to be making an object my array list, and we're going to basically implement an array list on our own. That's what we're doing here. So things that an array list can do. CRUD, create, read, update, delete. So we've already done create. That is our constructor. Next is technically read is next, but it's really hard to read when our list is empty. So we're going to do update first. Update, which includes add, right? We can add something. We can set something. We have adding. We have setting. We have read, which includes getting a value. And we have delete, which includes removing a value. Now, I know what array lists actually have accessible to us. And so I guess part of read should also be maybe like toString. I know what array lists have available to us, so I know what methods we need to write to make our secret my array list class act just like the built-in array list class. So the main difference between our class and then the built-in Java array list class is that we don't have generics. We can't store stuff in the exact same way. But that's why I'm using capital O object, because this will let me store anything, right? I can store strings in an object because strings live underneath that object umbrella. Heck, I could store exceptions in here if I wanted a list of exceptions. Anything underneath that object umbrella can get stored in here. So when we actually use it, we're going to use strings. But internally, I'm just going to use the word capital O object everywhere so that way, in theory, I could store not just strings in my array list. I could store anything. I could store person, objects. I could store anything inside my array list. Okay, so let's just do it in order. Let's start with read, even though there's nothing to read right now. We won't be able to test it right away, but that's fine. So the first thing we're going to do is read, which is a get method. So we're going to have a public object as our return type, get, and we are going to get whatever's at a given position. That makes sense. Now, if that position doesn't exist, so if the position is less than the cur number of items, less than or equal to, if this is 0 and this is 0, 0 is not less than 0. This is fine. If the position is less than the current number of items, we should probably be like nothing in that position. We don't normally want to just like print directly in here. So perhaps we make like an object to return. And we can just make to return equal null. So we can leave a little note here that says if object does not exist, return null. And then otherwise the object does exist. And so then to return should probably just be equal to the object at that position, items at position, and then I can return the to return object. Now it's just worth noting, I'm not going to do it here, but in the actual array class, this is not what happens. In the actual array class, if you try to get a position that doesn't exist, you actually end up throwing an exception, an array list index out of bounds exception, which we could do. We could say throw new array list out of bounds exception, and then be like, nothing in that position, right? So that it looks exactly like what you'd expect it to be when it comes to what an array list class actually does. But then I have to pull in exceptions and handle it. And I'm being a little bit lazy in my scenario here. So I'm just going to do a to return equals null instead. Cool. This is my get. The other part of get was like being able to, or the other part of read was like reading our list. So we should probably make our toString at the bottom here as part of read. So that's kind of low down. I feel like that's probably really annoying to look at on my screen right now. So public string toString, we're going to need to make some kind of a string, and we're going to go through the whole list for each element in our number of items, I++, oops. We just want to print out that information. Now, remember that all objects have a toString. They aren't always helpful toStrings, right? If we don't define a toString that's helpful, we get garbage, we get the memory address, but every single one has a toString. So we can go ahead and say items at I dot toString, and no matter what the toString is for that object, it's going to run. And if it happens to be a string, it will just print out the string very nice and helpfully for us. We'll put each one on its own line, and we will return result. Okay, so we have our toString in there now. For we have our read get and our toString. I will leave a little note in here that says all objects have a toString because of the object umbrella. Oops. It just might be the memory address instead of helpful information. Okay, there we go. So now we have our toString and our get. Now we can do our adding and our setting. So just like you can add something new to an array, you can add something new to an array list. Public, ours is just going to say, I guess we can return, I think typically it returns a Boolean add, and you're going to take in some object that you want to add. Now, as long as there's room, as long as the position is less than the item's length, whoa, not position, as long as the cur items is less than the item's length, we can go ahead and add that item to the list. Items at cur items is equal to add. And that will just add it to the list. But what do we do if their cur items is equal to the length of the array? Well, this is actually exactly what ArrayList does. If the array is already full, double the size and copy it all over. So if our array is already full, we actually have to make a brand new array of this size. I called this size increments because originally I was just going to like increase it by 10 each time, but I think it's more standard to double it. So let's just call this initial size. And then here we can just take the old size of items and multiply it by 2 so that we can get double the size of the original array. And then we need to go through every single element in the items array. We know it's full because the only way to get into this method is the only way to get into this else is because our items and cur items are the same. So we know that it's full. So this doesn't have to say cur items. This can just say items.length. And we need to copy over each element in there into our new array. Equals items at I. Now the question is, does this need to be shallow or deep? And the answer is it actually doesn't matter in this scenario because like shallow will work just fine. We're not actually changing any of the information. We're just moving it into a different place. So we just move every single element over into this new array. And then once we're done, we can say items is equal to our new array, so that now our internal variable items is looking at the new array. I'm going to show all this in a picture after, don't worry. And then we can add our new item to the array, because now there'll be space. We doubled the size. There's definitely going to be space now. And then we can return true, because no matter what, we're going to add the element in. In both scenarios, we add the element in. I can't actually remember what add returns. I think it is a Boolean true though. And we will look at that in the Oracle documentation later. Now there's different ways to do add. You could add an object, and this one will add to the end of the array. It's also possible though that we could add an add method with int I and an object, where we add an object in spot I and shift everything over. So that's another type of method. You can do this one on your own if you want to do on your own, because it's a lot of work to write a method like that. Same with set. I guess we can do set though. Set's a little bit easier. Set typically would take in the position you want to set at, and then the object that we want to put there. And then we can go ahead and once again make sure that the position is less than the current number of items. So we have to make sure that that's a position we can set. If it isn't, then normally this would throw an exception. But for our cases, we're just going to return null. We're just going to do what we did for the get. If the position doesn't exist, we can't set anything. So we're just going to return null. But if we can set something, typically what you return, object to return, is the current value inside the position. So we're going to grab the current value inside the position. We're going to reset the position to our new object. And then we are going to return the old value. So we kind of do like a swap there. And again, I'm going to show all of this in pictures. And then delete would be very, very similar. There are two different types of deletes. There's delete one, where you delete based off of the object and you go looking for the object. And there is also a delete where you do it by position and you delete for a given position. This one would return a Boolean. Like if it found the object and deleted it, it would return true. And if they didn't find the object, it would return false. And then this one would return an object similar to set. It would return the object that you deleted from this position. So you'd save that object, you'd shift everything over, and then you would return the object. So these are, there's a few methods here, 2 deletes and an add that you can do on your own, because I'm not going to fill all those in because it is so much work to set up a fully functional, partially filled array/array list on your own. And this is actually why, how nice, we have a built-in one. Now, before I go ahead and show the built-in one, what I'm going to do is I'm going to flip my video here to my tablet so that I can just draw this for you all. Hold on, I'm just dealing with my cords here. Allow. We are going to share my iPad screen. Trust. Allow. Perfect. Okay, so imagine this is, hold on, I better change the size of my writing or it's going to be massive. My ArrayList class. And we start off with an array in there of size 10. This is not going to look nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that 10? I'm so sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's right. And we start off with cur items is 0. Now, the first thing that we wanted to be able to do was add, and adding looks exactly the same as a partially filled array, where every time you would call add, you would just add more information into here, whatever you wanted to add, however you wanted to add it. You just keep adding it. Apparently, I'm adding it in the order of increasing in value. And then as soon as we hit an add that would stop us in our tracks, because we now have cur items being 10 and our size, our length of our array is 10, what we actually would do is we would go into that else statement in our block. And in that else statement, what we did was we made a new array. So this is like our items array. We made a new array that was twice the size of our items array, like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I ran out of space. I'm sorry. And then we ran our for loop that literally copied over each of these elements into their corresponding spots. 1, 2, 3, 9, 10, 14, 16, 21, 23, and 25. And then once that was done, we made our items equal our new array. So we severed this connection right here, and we made this equal to this so that we didn't lose it. Now notice that nothing is looking at this old array anymore. So garbage collection is going to come and clean that up. Then we can add whatever our new value was to this spot. Cur items did cur items plus plus. So now there's 11 items in here. And then when the method add ends, this disappears because we don't have access to it anymore. And all we're left with is our items array, doubled in size, all of our information available. And now getters and setters, right? If we get a value, we just make sure it's within the appropriate amount. Setting is exactly the same. If you did an add, if you had to like add a number right here, all of these would have to shift over exactly as you would expect them to. If you did a remove, like if you removed this number, all of these would have to shift this way, and you'd have to decrease your cur items exactly as you'd expect it to. And your print only prints the cur items. It doesn't go and print all these empty ones. So those work exactly like a partially filled array would, only now we put it all into a class called myArrayList. And when we run out of room in our array, we increased the size and copied everything over. Okay, let's go back to our notes for a second. So this is literally what the ArrayList class does. We have add, where you can add in a given position, like I had mentioned, but didn't code, or you can just add to the end. You can, oops, and it says it always returns true. So that's what I had as well. So that's perfect. There is a size. I forgot to make a size method, but we can add a size method that literally would just return our cur items, because that's how many elements are in there right now. So size always returns the number of elements, not the space. It's annoying that it's size and not dot length, but it is just a different name. Welcome to computer science. There's the dot remove, and there's two different versions, and they do exactly what I said. Remove int I, that one will, the index one will remove the element at index I and then return the deleted element. Whereas the remove for object E goes to try to find that object, and if it finds it and removes it, it returns true. Otherwise, it returns false. And there's a dot clear, which empties out everything. So that's like a delete all, and that one doesn't have a return type. And then there's the get and the set, exactly as I wrote them, except that the set would return the old element as I wrote it. And of course, our toString as well. Okay, let's look at some of that code. So we made our ArrayList class right here, and we made like an add method that would take in like a string one, right? We did make that, and we made our toString. So like if we run this code, we hope it's going to work. Oh my God, it totally worked. Good job, us. Okay, that's fantastic. Now, it's just worth now seeing that we're going to add that import statement back in. import java.util.ArrayList. And we're going to make an array list of strings. This one we'll just call A2. And this will be a new array list of strings. Whoops. Like this. So this calls the array list constructor, but this is like the built-in one, not the my array list. But it can be used exactly the same because we made it so that it can be used exactly the same. And then we can print A2. This one will have a different printing style. It'll be whatever the built-in printing style is. So you can see it printed in square brackets instead. We can do another add, another string, and over here we can do another add. Hippo, I think, was one of the options from the slides. I can't remember. Oh, I forgot a semicolon, sorry. Okay. There we go. We can see string, another string, because we put ours on separate lines. This one fills it like this. Now, I didn't actually make the index add method, but there was an index add where you could like add to a specific position, front add, and it would shift everything over. Now, I didn't actually write this method, so I can't test that on mine, but we can see it working in the built-in string. There is a set though for both. We did a set a1.set if we want to set front. This does return something, right? We talked about how it would return something returned. So it'll return the old value that was there. So we can even just show that old. And then down here, we can say a2.set in the front, set front. Oops. And it will also have returned, we can return it as a string because this one uses the actual string value there, string S, and then we can print out the old one here and do that. Okay. So now let me just clear this so that we have it nice and clean and I can, oops, I keep pushing the wrong button, run it. We can see old here for setting, object returned AO1.set returned null, which if we look at our method is because right here, the position, I did this incorrectly. That's why. Oh, I'm so sorry when you're watching a video and you can't like yell at me that I'm making a mistake. If the position is greater than or equal to the current items, it's not one that we can set. Or if the position is less than 0, we also can't set it. If somebody tries to set the position -1, we can't set that. I was thinking about just this one case and how that would work when cur items was 0. But as soon as cur items got bigger, this stopped working. So I'm really sorry about that. Let's rerun this code so that it works properly now. There we go. So string 1 got added, another string, and then we set the front one to be called set front. So this object got returned and the object was indeed old. And we can see now that when we print out A1, it printed out set front and then another string because it replaced string 1 with set front. And the same thing happened over here in our second array list where we added string 2 and hippo. Then we switched 0 out to be front add, which means string 2 got oh, sorry. And then, so then this got added to the front. So we ended up with front add, string 2, and then hippo. And then when we reset the first element, front add got booted out and set front replaced it. So then we had set front, string 2, hippo, and then our program ended. So we can actually see how those methods work. We can also look at remove. I didn't write the deletes over here. Technically, they're called remove when it comes to ArrayList, so I suppose I can do that. But I can test the ArrayList remove here. So I can do ArrayList remove. I can remove at a given position, and this will return success or not success. Success. Was there a successful remove? We can find out. And then I could also do a remove of an object. String remove, a2.remove, hippo. And then I can print out the entire fixed up array list. And I did those backwards because of course I did. This one should be a string. And then this one should be the Boolean. So if it removed it will remove whatever's at that position, nicely like that. And then if the remove worked, it will return true. Let's also do a remove for something we know isn't in there, like this. Like we know that's not in there. So now we should get one true and we should get one false. Let's try to rerun that. Okay. Okay, so just looking at the bottom ones here, after we printed out our whole list right there, we did a remove of 0. And then we did a remove of hippo. So remove of hippo worked well. Remove of 0 also worked. I didn't print it out, but it would have removed set front. And then we know that removing hippo worked, and we can tell that all that worked because when I print out A2 down here, all that's left is string 2. But we can also see that when I tried to remove garbage, it returned false because that didn't exist. So we can just see some of the methods that we have access to now that we have ArrayLists. Okay. Now the ArrayList class, there's also additional methods that we have access to, like index of or last index of, where you can pass in the variable that you're looking for. So like if you're looking for a string value hippo, you can pass that in and it works just like the strings index of or the strings last index of, where it will return the position of the first occurrence or -1. And in the last index of, it returns the last in the position of the last occurrence of that object in the list, or -1 if it doesn't exist. And both of these are calling on a method that is an equals method to check to see if it's in there. So if you have an array list of your own people objects, which we'll look at later, you'd have to also make sure that you had an equals method for your people objects so that if you call .index of, the code can go and use your equals method because you have to define what constitutes two elements being equal to each other. If you don't, write it exactly as I show, Boolean equals object, whatever variable name, it will just do an equals equals comparison instead. And with objects, as we've said before, we don't want to do equals equals. That's not super helpful. We want to actually define how we want to compare our objects. So we want to make sure we have a method in our objects class called Boolean equals and then whatever object element. There's also a contains method that works very, very similarly to the index of, except instead of returning the position it found it at or -1, it will just return true or false, which can be helpful. Basically, all it's doing is the index greater than or equal to 0? If it is, it was contained in the array list. If it wasn't, false, -1. It wasn't in the array list, but again, that means that this also uses an equals method. So strings, they have an equals method. If you have an array list of strings, all of these work really naturally and easily, and we'll show that in just a second. But if you have an array list of person objects, you have to define it yourself. So let's just take a quick pause there to get rid of some of this code. Ugh, I bet you want me to upload it. Okay, I'm going to leave it. I'm going to be so nice. I'm going to leave it. And instead, I'll make a new one, public class array list built in. And this one will just focus on those other methods that we just saw. .java. And we need to import our array list, import java.util.ArrayList. Oh God, spelling. Okay, there we go, java.util.ArrayList. And now we can make an array list of strings again. Our list equals new array list of strings. Okay, so now let's just add some stuff to our array list. And we're just going to do it one at a time. We're going to add animals. We'll add a dog. We'll add a cat. We'll add, I'm just going to copy paste a lemur. We'll add a zebra. They're not in any particular order. We'll add a gecko. and we'll add a fish. And just to make sure that this worked, we will print out our array list. So let's just start with this. Okay. Let's compile our Java file and let's run our built-in ArrayList method here. So there we go. Dog, cat, lemur, zebra, gecko, fish. So that worked beautifully. All of our ads worked. Let's actually change this so that like we just have an example where we're doing an ad to like a different spot so that fish ends up at the front of our list. Good. So now fish, even though we technically added it last, it's being put at the front. And let's just do one more with a set where we're going to set the second element. So it is gecko, but let's change it to pig. So now we should no longer have gecko in here, or sorry, we should no longer have dog in here is what we end up removing. We should no longer have dog in here. We're going to end up with pig instead of dog. Awesome. So that totally worked. So we can see all those. Now let's see what happens when we do, let's just print out the size of our list, just so we have all the examples in here of all the things. Are you kidding? There we go. Let's just put size. Okay, so we have size 6, so that's great. And let's do a remove. ArrayList.remove at spot 4. Ask yourself really quickly, what is going to be removed? Given what we know about our list, we should print it here just so that I can see everything nicely. There we go. So if we know that this is at 0, this is at 1, this is at 2, this is at 3, this is at 4, this is at 5, we should be removing zebra. And so our size should go from 6 to 5, and we should be able to remove zebra. So let's run this and make sure that that is what happened. There we go. Fish, pig, cat, lemur, gecko, zebra's gone, and we went from 6 to 5. So that all worked beautifully for our gets and for our adds and sets and removes. Okay, next thing that we're going to try is the contains. So let's ask ourselves, contains pig, question mark? And we're going to do an ArrayList.contains, and we're going to go looking for pig. And as we just saw, if we just scroll up a tiny little bit here, pig is definitely in there, so this should return true. Perfect, pig is totally in there. And if we want to go looking for aardvark, we know that this should probably return false. Aardvark doesn't exist in here. We never created it, and we're getting false. Perfect. We can also see how index of would work, but it's exactly the same as we would expect based on what we know from strings. So we just change contains to index of. There we go. Index of 1, 0, 1. It's in there. Okay, so there's a lot of things that I can ask you at this, especially on term tests. Hint, hint, nudge, nudge, because I can ask you all sorts of things like giving you a crazy line of code and asking you what's going to print out. So imagine for a second that this was our what we had, like these methods or these ads here, and then I gave you this line of code here, and I said what is going to and I added the following: ArrayList.remove, ArrayList, oops. Sorry, ArrayList.index of lemur +1. And then I asked to print it out, and the question is, what is our final array list here? And you would have to be able to then walk through the code and understand exactly what this line is doing and what would be printed out here. So you can start to combine them in ways that become really not intuitive at all, which is obviously why I don't recommend writing it like this. But understanding what's happening here is first, we're going to go find the index of lemur, which is going to be 0, 1, 2, 3, 4, no, 0, 1, 2, 3. Then we add 1 to it, so we get 4, and then we removed that 4th position. So we end up removing zebra from this list. So we end up in this list having fish, pig, cat, lemur gecko. So we're not removing what's at lemur. We're actually removing what's at the spot after lemur. Okay, cool. So that's all the like basic methods for array lists. So we have get, we have creating them, of course, and then we have get, and we have set, and then we have two different types of adds, two different types of removes, and a size. And that's it. I know it sounds like a lot, but it's actually not so bad. Here is kind of an overview where we can see the array versions versus the array list versions. Now, the arrays, we give it a size in its instantiation, and an array list we don't, but we do have to specify the type for both. For an array list, for an array, when we look at the length of it, once it's set, that's what it is. And if you want to make it bigger, you have to make a whole new one and copy all the pieces over. And while technically that happens, in the array list, we don't really look at the length of it. We look at the size and we look at the number of items in it that way. So the length of an array gives us how many spaces are available, not the current number of items in the array, whereas a.size for the array list is actually giving us the current number of elements in the array, not the length of it. Then we have our getters. So how do we actually access any element? So in an array, we use our square brackets in the index, whereas with an array list, it's a method. We say a.get and pass in the index. And same with setting values, so updating values. We have array at spot I is equal to test. Here we have to call a method, a.set, give it the position in the round brackets, and then give it the new value in the round brackets. We also have two pretty helpful extra methods that we don't get with arrays. We have a.add, which allows us to just automatically add to the end every single time. We don't really get that with arrays. You technically use like a set in an array, right? If you're going to add it, you're just like setting the position. It's not really an add. And then there's not really a remove equivalent either. Again, you can like change your cur items to be a remove as a way to like fake deleting something, but it's not the same as the array list remove, which does an actual true removal of that information from the array list. From the array list. But then of course, an array can hold any data type at all, including primitives. So ints, longs, doubles, chars, etc. Whereas array lists only hold objects. And so in the next video, we're going to talk about how to get those ints, doubles, booleans, chars into array lists. Since at this moment in time, we only looked at it with strings and capital O objects. So in the next video, we're going to look at how to actually do that with the like primitive number types and stuff like that. So now, I think this is my last slide here. Yeah, so it's up to you if you want to stick around or not to watch how to do these examples. But basically, I thought for pause and practice at this point, I would do at least one of these two examples, and then you could do the other one. Or pause this video, do it on your own, and then move on to the next video after. So let's start with building an alphabetical list of words. I'm going to do that one from scratch, and then I'll leave the removing duplicates from a list of words for you to do, because basically you can use my example one as a starting point to then do example two by removing any duplicates that got added to the alphabetical list. So that's okay. So let's just do example one together, if you're sticking around for it, of course. Okay. Here we go. We're going to make a new one here. Oops. Public class build alphabet list. That almost is a thing. We're going to save this as a .java file. We're going to import our ArrayList class. Okay. Next, we are going to, sorry about that. I, as part of my video, I had to step away for a second. So I lost my train of thought. Okay, so the very first thing that we're going to do to build out our alphabet list is, of course, put our main method in here. And we're going to build it out by asking the user to just give us words. So we're going to probably need scanner, which also tells me I need another import statement. Import java.util.scanner. Okay, so now I can use scanner and pull in some information from my user. And then I'm going to say enter a word or type Q to exit. And what we're going to do is we're going to let the user enter a word, and they're going to be allowed to keep entering words until they type Q, and then the game, like the activity will stop here. And basically every time they enter a word, I'm just going to print out the whole list with that word inputted somewhere in the list. Okay, so while, I guess I have to store the user's information somewhere. Pardon me, sc.next line. And while line dot equals ignore case. So while it's not Q, we're going to add to list, print list, and ask again. Okay, so we're gonna have to ask again. That part's really easy. I can do that right here. I'm going to also add my end of processing message down here. Now, in order to add to list and print the list, I actually need a list, which I don't have right now. An array list of strings. Alpha. New array list of strings. And we know how to add to a list. Whatever they enter, I can just do alpha.add. I know that this isn't totally right. Just bear with me for a second, and then we're going to print out our list each time. I just want to get something in here so that we can try this out and just like see what happens. So if we try to run this code, and I do javac build alphabet, there we go, and I just want to make sure it runs, type in a word, W, hello, snack, that's supposed to say snack. Each time the list is getting longer, and when I type Q, it ends. So at least I know that my basic program works. Now, of course, the thing is it's supposed to be an alphabetical list, and right now it's not making it alphabetical. It's literally just adding it to the list no matter where, like to the end each time. That's what this line does, right? So what we're going to do instead is we're going to call a method for an ordered insert of some kind where we're going to pass in our list, and we're going to pass in the word that we want to add, and we're going to make a method elsewhere that's going to do this. Public static void ordered insert alpha comma line. And we're going to find the position to put this element in. So we're going to go through every single element in our list. So while our index is less than our alphabet.size, I'm just going to move this down again because this is kind of annoying where it is. So while our index is less than our alphabet.size and we haven't found the right position yet, alpha dot get at the index. Ooh, this is going to get messy really quickly. String L is equal to alpha dot get at index. And that element is, we're going to do a compare to, is less than 0. So while the current element is smaller than what we're trying to enter, I just realized I didn't put these in. We're going to keep going. We're going to keep looking for the right spot. We're going to keep going, keep going, keep going. So index plus plus. We're going to keep doing this all the way until we either get to the very end of our list or we find the right spot to put it in based off of our compare to. And then once we have found that position, we can go ahead and just say alpha.add at that position with the information we want to put in. Now notice that I don't need to return my list here because array lists are objects and objects are mutable. So it will automatically change the one up here when it gets edited down here. Let's see if this code works. Javax star.java, Java built-in whatever. Hello. Oh no, what happened? Okay, let's look. Index out of bounds exception, index 0 out of bounds for length 0. So check this out. Right here, the index being 0 was not right here actually is where the issue was, where we said string L is equal to alphabet.get at index, and this 0 didn't exist the first time that this ran through. So this came back as an index out of bounds because there was nothing the very first time this ran. So there are two different ways to handle this. The first way is to just say, if this is like empty right now, we can just add the first element in. Like we can just add it. It doesn't matter. And then everything else can just happen after. If it's the first element, just add it in because there's only one place to add it. It doesn't matter. And then everything else will happen every other time. So that's one way to solve this problem. Another way to solve this problem that I personally actually prefer, even though it's going to look a little bit messier, is that rather than like defining L right here, since we only use it right here, just taking this and replacing L there. Now this will work because 0 will not be less than 0. And so as soon as this becomes false, this won't even run. And so we won't end up saying .get index on something that doesn't exist. So if we run this now, we can see that happening. Hello. World. Apple. Brother. Lauren. And we can see each time it's actually adding it into the correctly alphabetized position, thanks to that compare to, doing a check to find the position, and being able to set and add really easily into the middle. We don't have to shift everything over the way that you would if this was like an array list. Or sorry, if this was an array. Okay, so it's actually a really, really simple program. So here's that simple program. This program allows you to add multiples of the same word, right? Except for Q. Try to type Q, it closes out, but everything else you can enter. And so using this as a basis, you can now try question 2, which is to now say when the program ends, like right here, add a call to remove duplicates, and then print alpha. So you'll call remove duplicates on the array list, and then print it out, and it should remove all of the duplicate values. So you can totally give that one a try on your own. Next up, we're going to talk in the next video all about how to get ints and doubles and things like that into these array lists. Since technically they are not objects, we have to use a little special mechanism to do it. So I will see you there.